to record. So prerequisites, list these in more general terms, in more of like maybe the skills or the topics a student needs to know before they tackle your module, and don't say they need, I don't know, Ecology 101. That doesn't help anybody. For the learning objectives, this does not mean your overall list of learning objectives that goes inside your module. What we mean here is just very high level, broad overview learning objectives of your module. Of course, add your course author information, target audience, tools needed, course sharing adaptation, and we have a suggested citation here as well. And I'm going to show you how to get to the About page, because again, it's really not that intuitive. So from inside of your course, the About page can be found by clicking on Settings and then Schedule and Details, obviously. So Settings, Schedule and Details, and your About page information starts under Introducing your course. So these are the things that I was listing here: your course short description, course overview, course card image. All of that information is in here. And you'll see, obviously it's an HTML edit box, but we have the structure here for you already and the formatting. So all you need to do is change the text in between these paragraph markups. So the titles are here to kind of guide you. So if you just watch out for the H2 style, you know that you need to add some information to switch the text here. Okay. So all of the information that is listed right here, well, is provided in the HTML. What you need to add is how people can share your course and how it has been adapted, and then include a suggested citation, which we have the formatting here. And then also include at the bottom, that's the hours of expected effort. So how long do you anticipate that it would take a student to complete your module? And then if you scroll below course overview, you'll see the course card image. You upload it and it'll change right here. Hours of effort should go here as well. So whatever you typed up here, just provide the digits down here. And then you can select your course content license type that you prefer. And we'll have more information on that later in the day. So do we have questions about the About page?
I have a question. This looks like the same information when we're looking at our template under, I know I've seen it.
I know.
Under summary, right?
It's given in the introduction part of the template as well. And I guess part of what Jenny is saying now came about with the discussion, because I raised the question that I think what goes in the introduction should really be student oriented, whereas what goes in the About page should be sort of faculty oriented. So I think at least that was the suggestion I was putting forth, was that's the way to orient how you separate what information to put in each place.
So we should take it out of the text in the summary. I think it's under summary, right?
Yes.
Yeah, well, sometimes some of that information is also valuable to give to students. So think about, I mean, for example, the tools needed and the expected completion time is valuable to students as well. How to cite the module is probably not valuable to students. So that's at least my thinking on how it should be organized, but we haven't necessarily as a team fully come into agreement on that. That was just my suggestion.
Thank you.
So something that's more related to the instructional content. Some of you may be interested in inserting a Google My Maps into your module, and these are dead useful to just make a map of the area that you are interested in or the watershed you are studying, area of interest. I won't give you a tutorial about how to make a Google map. If you're interested, maybe we could do that some other time. But rather, my point is to show you after you've made it, after you've made your map, you can copy this code here to embed on my site. And that is the iframe code that you are going to copy and paste into an iframe within your unit. And remember, if this is something that the students will be referencing more than once across many different units, it might be a good idea to include it as a page instead. So if you wanted to add a new page, just click the button. In the settings, you would change the title. So I'll say here, Google My Maps. And then go back, embed, and copy. Well, you get the point. For some reason, it's not copying, but it's, I mean, it's in iframe, and you're all iframe wizards at this point. There we go. And then the students would be able to view the page. It's across the top of the module. So regardless of what unit they were in, they could always come back and look at this map. And something that's also super useful about the Google Maps is that you can download in KML or KMZ and share it with your students if you wanted to as well. Let's see the chat. Okay. So any questions about my maps before I turn things over to Dave? Okay, I'll take your silence as a no. There you go, Dave. It's all you.
Okay, let's see if we can get the right screen shared. So I'm going to talk about 4 things that we've sort of started alluding to as we've gone through the workshop, but get into a bit more detail. The first is backups. The second is Hydroshare, which is a platform for sharing data and models that you're welcome to use. The third is getting into the details of actually working with data and code in a HydroLearn module. And then I'll also finish off talking about intellectual property. So in terms of backups, online systems such as HydroLearn, sadly, are vulnerable to data loss through system failure, hacking, ransomware attacks, etc. We haven't had any, and I hope it's we don't get in the future, but there's always a vulnerability. We are following the best practices to protect HydroLearn, but there's also things you can do to try and keep your work safe too. Note that HydroLearn is hosted in Microsoft Azure, which is a large cloud system operated by Microsoft. So we effectively rely on them for the system support. It's backed up daily and backups retained for 30 days. Those are to a US data center, and they allow, in the case of a catastrophe, complete restoration of the system to its state at the time of the backup. But it's not possible to restore individual modules separately. So you might sort of think of that as a limitation. If something happens just to your module, it might be rather drastic to sort of try and restore the entire system with changes that might then get lost to other modules due to just one module being perhaps damaged or compromised. So keep that in mind. And here's what I suggest as your responsibility, really to protect the work that you are putting in HydroLearn, which is now growing. Keep copies of your sort of intellectual work, your writing, your figures. I like to do my writing in a document on my own computer, such as Microsoft Word, and then cut and paste it into HydroLearn so that I've got the copy of the paragraphs I wrote. That's really my creativity retained for me. Try and keep your credentials secure. I mean, if your account is hacked and content deleted, restoring an individual module is difficult. The backup protects the entire system. And then periodically export a backup of your module, so it could be written to a new module to retrieve content. So this is the mechanism that's also used to share modules, and you use that right at the beginning when you exported a copy of the course template and then created your own course from it. So periodically retaining a copy by exporting your course, keeping it tucked away on your computer someplace, especially perhaps before and after making significant changes, will help protect your information. So that was just a little bit of information I had. We could go into more details, but any questions about sort of backups and keeping things safe? We really hope that we don't have system failures or get hacked, but we have to be careful. Okay, not hearing anything. It looks like everybody's happy with that, and not seeing anything in the chat either. So the next thing I want to talk about is much more exciting, Hydroshare. So Hydroshare is a community platform supporting water resources research. It's operated by Quasi with ongoing development amongst those institutions listed there. I'm the National Science Foundation principal investigator for the development of the system, and it's been really nice to see how it's come along and started becoming a resource for systems like HydroLearn to use. So if your module requires data, consider using Hydroshare, and this way you can help make your problems authentic. Maybe you've got real research data in Hydroshare linked to a research paper, and you could use that in a module, as well as familiarize your students with a system that's being used in research. So there's a couple of key concepts that are in play here. First is that data and models are first-class products of research and should be shared. They then become social objects. So it's not only the scientific papers we write, but also the data underpinning them that needs to be out there for people to use and develop trust in the research work we do. On the right here illustrates some of the sort of things, the sort of data that can go into Hydroshare: time series, geographic information in terms of shapes or features, raster information, multidimensional information, and even a model depicted here as a little bit of a flow diagram. All of those are referred to as resources in Hydroshare. We use the word resource to sort of be more broadly encompassing beyond just data. And then if you're doing a research project, the data management, working with information in Hydroshare should really start at the beginning of the project. So there's a way to first put information in that's private, then just shared with your collaborators. And then eventually, as your paper gets published, it might be made public. So they'd be systematically managed through the full life cycle of the research, which actually allows it to grow. As you find that there's additional README information, additional metadata needed, you can tweak it and add it. And I'll show an example of that a bit later on. So if you think of, this is the sort of workflow a user might go through in terms of sharing their research to enable transparency. They would create a data set, upload it to Hydroshare, then share it with a research team. Maybe if you're doing it in HydroLearn, it might be you, or it might be the two of you working on a module, or it might be you and some graduate students. Then the final version would be published and assigned a digital object identifier, and then the user would cite that in a paper. This is not so much a sort of a HydroLearn consideration. And in fact, we would probably think of not going to the final assign a DOI as the best practice for data being used in a HydroLearn module, because once it's been permanently published with the DOI, you cannot change it, because a digital object is supposed to be immutable, and you might work with data. You might want to, for the next class, update the data. So just leaving it as in public without it being sort of finalized is probably best in an educational context. So there's also, and this is probably where the linkage to Hydroshare will become most important, there's functionality that supports a gateway to computing. So the picture on the left sort of just schematically shows that Hydroshare is first a website where you can go to manage data, but then it's also got linked to it apps, web apps that you can open with a Hydroshare resource connected to the compute app, and you can do various work within it depending on what the apps are. So what I've got depicted on the right here is a Hydroshare resource landing page. It's got a title, authors, the sort of metadata that we keep track of, content types, an abstract, and this one is public. Then at the top, there's a button that says open with, and you might choose to open it with Quasi Jupyter Hub, and then it would open this Jupyter Hub window, and you might see a file that says IPYNB, and that's the sort of keyword for a Jupyter notebook that you can then have your students execute code in a fairly simple way to do useful work. So there are two Jupyter Hub instances connected to Hydroshare. One is operated by Quasi in the Google Cloud. The other is operated by the University of Illinois collaborators, the CyberGIS team in the NSF Exceed system. And those are really just different ways of exploring how to develop that capability. It's really cool to take advantage of the Google Cloud, but Quasi sort of has to pay for that on a per use basis. The CyberGIS one is free in some sense, in that once you've written a proposal to NSF, it's provided for free. You still have to put the time and effort into writing a proposal, and given that time is money, it's not exactly free. Then you end up with a Jupyter Notebook open. If you're not familiar with that, it's a sort of a word processor document looking thing that has plain text and code blocks interspersed. And each code block you can run and do various things, and the intention is to use the explanatory text around it to explain what's going on. And I'll show a couple of examples of that. So I'm going to now switch into actually working with data and code in HydroLearn, and I wrote a little HydroLearn module called Embed Code to illustrate that. But before I do that, any questions about Hydroshare before I jump in there? So maybe I should go back there, or even there. Okay, any questions?
Dave, I had a quick question. And so you reviewed our model, and one of the things that you talked about was just the availability of data from the USGS. And so I was just wondering, rather than Sam and I acquiring those data from the USGS and putting those data in a zip file, would Hydroshare be an appropriate venue for that? I mean, it's not research, right? But then, yeah, exactly. So it's not research, but then it's a resource that potentially could be used. But is that an acceptable use of Hydroshare if we just get data from the USGS and package it in a way that students can access it?
It's certainly an acceptable use of Hydroshare if you've got, say, data that you've needed to or chosen to repackage or to simplify for a particular exercise. I would, though, try and see if you can actually have the students use the data directly from the USGS, because that actually is how they would have to work in the real world. That is the sort of authentic problem, the authentic solution to the problem. Now, you do face a challenge with some federal data sources, and the USGS is probably one that you'd face the least of that challenge with, in that they don't maintain a stable system. Periodically, they'll change their formats, which can break your modules. The USGS has been pretty good about making certain of its data, the National Water Information System, streamflow data, for example, available in a very standard, persistent way. So if you can have the students just use that, I think that would be good. And maybe the comment on the module was that you sort of hadn't done that yet, and it just said use USGS data, but didn't say where to get it from the USGS.
Thank you.
Okay. Any other questions?
Yes, David. So can you briefly tell me if I can set up an account and be able to code with Jupyter, do I have the ability to access the data available at Hydroshare and other quasi resources?
Yes, you do. So, and I'll show an example of that a little bit later on. But basically, this button that's on a Hydroshare resource, open with quasi Jupyter Hub, ends up copying the data from that Hydroshare resource into the Jupyter environment ready for you to work with.
Okay, thanks.
Any other questions I should pay attention to if somebody's got their hands up, because I saw you had your hand up there. I didn't notice. Okay, so in terms of working with data and code in a HydroLearn module, the question comes up, is it possible to set up a system for students doing a module in HydroLearn to run Python code directly from an online console without installing Python on their own computer? And if so, how can data be accessed by the script? Now, this is an advantageous thing, because one of the things that cloud compute systems in general, and Hydroshare in particular, provides is sort of pre-configured environments. Students don't need to fuss with installing anything on their own computer or worrying if their computer is the right type. Is the example you've developed for a PC or for a Mac, or do they have enough memory? Those are always problems that come up when students are doing their computing, and working with systems like Google Collab, which I'll introduce in a minute, as well as Hydroshare's compute parts, gets around that. So there is this module, HydroLearn Embed Code, that I've developed. I developed it in time for last year's workshop, and we'll go through that. There's one slide on Google Collaboratory here that I wanted to go at first, that basically just points out that Google Collaboratory is Google's effort to support simple Jupyter Notebook-based computing for the masses. Given that it's being done by Google, it's obviously big and very well done. And this is a resource that's definitely worth investigating. And one might suspect that Google may be around longer than Hydrolearn and Hydroshare, perhaps. So it's definitely worth looking at. And I guess these are examples of Hydroshare of Hydrolearn modules that take advantage of Hydroshare. This one by Belize, and an example of a module that takes advantage of Google Collab by Josh Roundy. And let me go and exit out of the slides. And okay, so here I've got my browser, and I'm looking at the list of resources in Hydrolearn, and one of them is Hydrolearn Embed Code, which is guidance on embedding Python code into a module. So I'm going to open that and expand all parts of it and go to, well, I'm just going to basically step through this. This is a very short module. In passing, I guess Jenny showed earlier about how to get to the About page and how to edit it. One thing that I found useful with Hydrolearn is you can actually, where you've got this edX address here, you can replace the word course at the end by About without a trailing slash. And that gets you to the About page quite quickly. I wish there was a way that didn't necessarily require you to edit the address bar, but I found that handy. So this module, there's a problem statement that I just read to you, setting up a system for students to learn to run Python code directly. The topics are Google Colab and Hydroshare, and you need a Google account, and you also need a Hydroshare account, and I think you can probably do it in about an hour. So let's go back into viewing the course and the module overview. I try to frame it using the standard Hydrolearn recipe where we state learning objectives. So you should be able to execute code for simple data using Python and Google Colab, and also execute code for simple data using Hydroshare. So there's the section, the subsection activities, and where those learning objectives are addressed. This is the actual activity. It illustrates a Jupyter notebook containing Python code saved in Google Colab for doing a simple hydrologic analysis. It needs data. So here I've actually done what I was just being asked about, what Alex has just asked me about. I've actually got a USGS Streamflow file, and I've put that in Hydrolearn, so it's always part of this module. And I've also put a Python code file in Hydrolearn. And if I follow the instructions of this learning activity, it says to click on the links and download them. So I can click on that and save this page as a text file. So this is a standard USGS text file that you might get from the National Water Information System. I'm gonna do the same for this little bit of Python code. So here we're getting into code. So if you don't know Python, don't panic. It's a fairly simple language, and this is short, and hopefully you'll get the gist of some of what it is. There's comments that say this is a function to read the USGS stream flow. This is a function to read data from Snowtel, and I'm going to save that onto my desktop as well. So then in the notebook, open the Collab flow from Snow Notebook below. So I'm going to click on this big blue button, and then in the notebook, I'm going to click through running each cell and following instructions. And it's going to warn you that it was a notebook authored by me, and you need to sort of trust that it's not going to do anything malicious, because you are actually executing code provided by somebody else. So notice now that I'm at a website, collab.research.google.com. So I'm running inside of Google, and this is a Python notebook. So Python is a subset of the languages supported by Jupyter Notebooks, and it explains here that it does some simple data analysis using USGS Streamflow. It comes from this Hydrolearn module developed by me. So I'm trying to put descriptive text right at the beginning. The first cell below, a user should upload a file obtained from NWIS, and there's an example file in the Hydrolearn module. So here is a little bit of code. From Google Colab, import files and then upload a file. So it may take a little bit of learning to figure out what that code is if you're not a programmer, but learning from examples like this is often a good thing. If I just click to run that, here's where we get the warning. It was authored by me, and it might request access to your data stored in Google. So if you have concerns about a notebook, you have to sort of check it out with the author. So I'm going to say run that, and here it's now prompting me to upload that file. So I'm going to browse and pick that file that I just downloaded, the USGS, that gauge number, and open that, and it progresses through, and eventually it'll be uploaded. So you might wonder where that is going. It's going somewhere into the storage space associated with your Google account. And I was actually logged into a Google account, and I know that by the fact that it says, got my little picture there with, that's the Google account that I'm logged into. And you can click on this little files thing on the left to expand that. And now you see a sort of a tree with the data that you've got. So it's just uploaded this single text file here. And perhaps I should have shown that to you before we uploaded, and then you would have seen that that file was not there. But I'll do that with this one. So this notebook has been developed to illustrate working with user-supplied data as well as user-supplied Python code, the get data functions Python file. So now I'm going to upload that code file the same way that I uploaded the data. So it gives me an option to browse. This time I'll select that Python code, and it's uploaded. And in a minute, when this refreshes, or I might have to refresh it here, you'll see that that's also a file in the system. So the files you're working with sort of are depicted there. There's a button here that you could mount your Google Drive and access the files in that, and then you would then be able to copy these files there as well if you want to save it in the Google Drive associated with your Google account. So now this cell just effectively makes reference to some of the standard Python libraries we'll be using. We'll be using NumPy, a Python numerical library, and Matlab, a Python plotting library. So we're just going to import those functions. If I put these things in comments here, if you were working somewhere not in a Google Colab environment, you might have to install those. And then you would uncomment those and do the installs. If, for example, you were working on your own computer and you didn't have those installed yet. So I'm going to, you click on each cell by clicking on this little black circle with a triangle in it. And I'm going to run that cell. And after a cell has run, you see the number appear. So this was cell number 2. That was the third one that we ran. This next one is going to read the data using the functions in that Python code we imported. So the first function is read the USGS streamflow file, and you pass in the file name, and then it's going to make a plot of with X, the date on the X-axis and flow on the Y-axis. Then it's going to go out and read a SNOTEL site. That's a snow telemetry site. And here we've got a station identifier, a date, and a state. And we're going to make a plot of that. So the general idea here is we're trying to look at, see if there's a relationship between stream flow and the amount of snow. We obviously expect that if there's a large snowpack, the following year's stream flow, as may be measured by the maximum daily stream flow, may be correlated. So this just reads and plots the data. So if we execute that, there are two graphs. One is the graph of stream flow. The other one is the graph of snow water equivalent. And you notice a few other things appeared, or one other thing appeared here, snotel.txt. So this actually went out to the web and downloaded information from the Snotel site rather than it having to be user supplied. So this is another way that you might help your students use sort of real authentic data in a learning context. And if you look back at the code here, you can see actually how it was done. It says it's specifying the URL of a Snotel website and sort of constructing a URL for retrieving the data, then retrieving the data and putting it in a comma-separated variable file. And there's a website there that described the format of this that I used to sort of figure it all out. So then you might want to do some simple analysis, and here's a bit of explanation. And there's an explanation for what this code does. And what it does is it determines the maximum snow water equivalent. Then it scans the daily stream flow to determine the maximum daily stream flow, then plots the one versus the other and draws a best fit straight line. So this is a sort of pretty simple analysis, but somewhat authentic analysis, because you may be interested in how the maximum stream flow relates to the maximum snow, given that this maximum snow is observed a couple of months before the maximum stream flow. There's obviously a lot more that can be done, but here's the code for doing this little bit of the analysis. And if I run it, you get this plot of maximum snow versus maximum discharge. And there's a reasonable relationship, fair bit of scatter, and the code has reported a regression line that you could use for prediction if you so choose. And I guess you could also calculate standard regression statistics and output them if that's something that you want to do. So that's some of the things that you could do, and you might want to build learning activities if your module sort of has this sort of, well, if this makes sense in your module, and this was all done from a browser using Google Colab, so a student doesn't need to actually install anything. I'll pause there for questions if there are any.
There's a question for you in the chat, Dave.
Okay. Do we need to enter a credit card to create this Google Collab account? No, you don't. And I have not entered a credit card into Google. And I'm actually running this on my personal Google account, david.tarbutton@gmail. I am living within the free quota that Google gives everybody, which is 15 gigabytes. So if I was to have a huge amount of files, then it would be a problem. But I've not entered a credit card. But I mean, that is a Google may change its charging model at some point, and this is something you should possibly be a little bit alert to. There was another reason I actually ran it here in my my personal Google account, is that Utah State University also has Google accounts, and so you can get much more storage space in Google through the university. I actually put this notebook in my university account when I created it, and it's sort of saved in a part of my university account that I've committed to myself not to change to support this module. So if I had run this from my university account, I would have been working on the live copy that's available to all of you. And I didn't want to be potentially doing any of that, because every time you run things and it starts putting results, it's effectively changing the module. You can see here it says cannot save changes, and that's because my personal account does not have permission to change things on the university account, and I'm totally happy with that. If you work with this and you want to make changes, you'll have to click this button to copy it to your space, and then you can make any changes you like. So in my university account, I shared this notebook file with anybody with the link with view permissions, not with edit permissions. So you have to pay attention to that.
David, I have a question about the function, get data functions Python code that we load. Is there a pedagogical reason to have, because this could have been embedded in the Jupyter notebook? Is there a pedagogical reason to have students upload this Python file to get those functions?
Yeah, well, I did it because I wanted to show how you could use code provided in a Python file in addition to having code in the Jupyter notebook. Certainly you could have just embedded this in the Jupyter notebook, but sometimes when code gets really long, you may have a model that's in Python that you want to run. So I guess I did it pedagogically to show how to use a file.
Thanks.
Okay, so then I guess Nate's got some comments about RStudio Cloud changing to a pay-to-play system. So yeah, as we go through using web-based compute systems, you always have to worry about the sort of charging model of where the service is coming from.
Yeah, that was just a comment because it kind of wrecked half of my hydrology class last fall when they changed it the last minute before the semester started.
Yeah, yeah. So you have to always be careful for changes. And I went through over the weekend and redid all of this just to make sure that nothing in any of the systems had changed, so that it would work for you guys. And I did actually find there were, for some reason, my notebook is not working on CyberGS Jupyter for Water. It's working on Quasi Jupyter Hub, and the Google one's working. So thankfully, yeah, I don't know what the changes are. So then if I switch back to this module, this is here's text for do-it-yourself. So I've taken advantage of the Jupyter Collab X block that's provided in edX, that's which is where Hydro Learn is deployed, it provides effectively it provides a way to put this blue button in one of your modules. To do so, you have to go into the advanced settings, and I think Jenny was showing you how to get to the advanced settings earlier. And you basically have to add this little line of code here, collab_x block. When you go in by default, you'll find the first 5 rows are at the advanced module list. So once you do that and save that, then you get an option to add a component, add a Collab component, and you can follow this guidance and set its name, set the button text, put the URL for the notebook that you want to open, and then you will be able to go from there. Okay, so that was the Google Collab example. Now, if there aren't any more instructions on that, I'm going to go through the same sort of thing in Hydroshare. I guess, Anne, you've got your hand up.
Yeah, I guess my question was, what do you recommend doing if we're having them look at USGS data, sort of this type of data? Do you think the Google Collab is worth it, or should we stick with Hydroshare?
I think that they're probably, well, if you want to provide the data, it's a little bit easier in Hydroshare. If you're going to have them download the data from the USGS website itself, then they're pretty much equivalent. And it's a matter of what you think a preferred environment for your students is going to be. And whether students are going to be more comfortable using a Google account or a Hydroshare account. It's very little between it in terms of choosing. But I would suggest probably for any one module, you only use one. Because it's, yeah, you don't want to give students too much.
Okay, thanks.
So this effectively does the same thing from Hydroshare. So it illustrates a Jupyter notebook containing Python code saved in Hydroshare, doing a simple hydrologic analysis. So here's the link to the Hydroshare resource that contains the data and code needed for the analysis. It explains here how you'll need a Hydroshare account, and you'll also need to have joined one of the compute groups for working with it. And then, as I was checking yesterday, and I couldn't figure out why, the CyberGS Jupyter for Water is giving me a Python error that I didn't figure out, that didn't occur last year. So there's the sort of learning activity for this little bit here is open the Hydroshare resource, right-click on the open with, and follow the instructions in the notebook. So if I go into this Hydroshare resource, so this is the example resource illustrating the embedding of data and Python code. So this is another illustration of our Hydroshare resource landing page. You see I've set it to public, so anybody can access it, but it's not permanently published. So I'm able to change it. You'll notice that I did actually change it yesterday, and I added HydroLearn 2021 as the keywords, and I also tweaked the citation information. But beyond that, it was the same as from a year ago when I created it, June 2020. You can see it's got the Jupyter Notebook file, flow from snow. That's a little bit easier to actually get the file. You weren't exactly sure where it came from in this one here. There's the USGS data, the Python code, and I've also put a README file that renders down below that explains a little bit about it. I've got other sort of good Hydroshare practices. I've said this resource is described by providing a citation of the HydroLearn module. So this is how you might cite the HydroLearn module if you ever have a need to cite it. So the sort of citability parts of Hydroshare we've tried to pay attention to. And I've given the funding agency, this is developed with our NSF grant that's supporting the development of HydroLearn. So NSF can see that this sort of grant is producing these sort of products if they look at this. And then this is the information on how to cite a Hydroshare resource, and it's got the Creative Commons license on it. So I'm asserting on the web page anybody can use this as long as they follow the CC BY rules. And then there's also ability for people to comment on the module and ask questions about it. So that's what's in Hydroshare, and you could provide this Hydroshare link to your students as part of a module. And then you would provide instructions for them to go to, say, open with, and they would open with, for example, Quasi Jupyter Hub. That actually requires me to be logged in, so I'm going to do that, and it'll probably ask me to log in. So maybe it remembers me from yesterday. It does, because I can see it's got the account up there. The Quasi server gives you a number of options. You can run Python, you can run R. So I saw somebody was putting in the chat that you can actually run R notebooks in Quasi Jupyter Hub. You can also run R notebooks in Google Colab as well. So this one is actually a Python notebook. So I picked the Python environment. It's now going through the process of effectively copying those files from that Hydroshare resource into the Quasi Jupyter Hub platform, which is at that URL, jupyterhub.quasi.org. So this is the sort of compute capability linked to the Hydroshare repository. It's gives you these sort of snarky comments about increasing magnification to amuse you while it's doing the download. And eventually you end up with a Jupyter Hub instance running, and it shows you the flow from snow Python notebook, the functions that were used. It also downloaded this README file because it downloads everything from the resource that wasn't really needed, and the USGS streamflow data. So these are the files that came from Hydroshare, and you can just click here to run this notebook, and it's exactly the same as what you saw before. The cell that references dependencies, and I think it's good to have a cell at the beginning of every Jupyter notebook that establishes the dependencies in case somebody's running it someplace else for reproducibility. And I'm going to run them by just clicking the various things. You can also do sort of run cells, or run all, or run cells selected, and the like. Again, explaining where the data came from. The read data function, it's from get data function, so that refers to the Python file that was uploaded. So it's going to now read that. And there are the two plots of streamflow and snowball equivalent that we saw before, and then exactly the same analysis. And the same sort of regression fit that we got before. And if I flip back to the data contents, you'll see that it's added the Snowtail data that was downloaded. So you can do it with Hydroshare, and you can sort of embed data and code all in a single resource to provide for your students. Okay, and then looking at the comments, I guess Alfonso's chiming in that about Google Colab having Google preferred packages like Google Earth Engines and GMAP. And I guess you can, and we saw that with Quasi Jupyter Hub, request custom packages to be part of it. And you saw that when we opened it with, and I don't know whether it would do it again, whether it would, it's just downloading it again. I was going to see if it gave you the option to choose the various environments. You can get, you can work with Quasi to get your custom code be part of the system that they support. That's actually something that I don't strongly encourage. I think it's much better to have a notebook that's sort of self-supporting and installs its own dependencies at the beginning, because this makes it runnable anywhere. Whereas if you're going to rely on Quasi's dependencies, it limits whatever you've done to only running on the Quasi platform. But sometimes if it's a really complicated thing, that simply installing it like this is not going to work, that might be a good solution. So I guess then the do-it-yourself, create a new Hydroshare resource that holds this data and code that you wish to share with your students, make it public and link it from your module. And I think that might actually be the last page. Oh, no, it's not quite that. Any questions on the Hydroshare one?
So David, can you also use this this platform to share data that is associated with journal papers that you publish?
Yes, and that's actually the primary use case of Hydroshare. So let me, I could show you an example of that. So if I go into Discover, let me just do, okay, so here I was just looking for a particular set of things. This this says this is a published resource, and if I click on that, geospatial analysis of tree cover for streams in the contiguous United States, published by these people, and it's related to a paper by that person, and somewhere you should say this content, the content of this resource serves as the data for this paper. So here we've got a published paper and the associated data. The data is in Hydroshare, the published paper is environmental modeling and software. So the cross-referencing between that is something that we yeah, that's one of the major use cases of Hydroshare. So Alex asked, if we offer one activity on Collab or Jupyter, but the student is more comfortable in something else, should we be strict on the tool, or can we let the student choose his or her favorite tool? Well, I mean, that's sort of an instructor's preference. I mean, I would let a student use their favorite tool. with the warning that I may not be able to help them if they run into trouble, because I may not know how to use their favorite tool. But you should think about whether your learning objective is for the student to learn the subject matter with any tool, or whether actually learning a specific tool is one of the objectives you want them to take away. Okay, so then I'll also point out the last page of this module talks about Matlab. So I haven't worked with this very much, but Matlab Online is available through a quasi partnership with Matlab. And you can launch it from Hydroshare using OpenWith, just as we did the previous ones. And here's a Matlab resource that was prepared by Tony Castronova. And I don't know the degree to which this still works or not, because I'm not it's been years since I used Matlab for anything serious. But you can open this with Matlab Online, and I guess it's wanting me to sign in and authorize that to access my Hydroshare data, agree to whatever their terms of use are. Hopefully it didn't say they're going to charge my credit card, which hopefully they don't have. And now you're in this Matlab environment that Tony Castronova set up. So I just mostly provided that for reference. If you're familiar with Matlab, this will look much better to you than it does to me. So you got options: R, Python, Matlab, which probably cover a large number of the computing capabilities that we might want our students to use.
Dave, I just pasted in the chat box a link to one of the sections in one of the modules on how to learn that actually used Matlab the way you described it. So yeah, I guess you have to enroll.
There it is.
It's open. If you enroll, I guess you need to enroll to be able to see the section. But again, enrollment does not cost anything.
So yeah, so you guys could go and check out this
Yeah,
this module that used Matlab for another example.
yeah, it's the section on learning activity 2. So that's if you are interested, you can almost go there and copy and paste the code or how they did it, because they have instructions on how the students, how they can open Matlab from HydroLearn. I mean, the way David described it, this way you don't have to write everything again. But that's the name of the course, and that's the name of the activity that used Matlab. It looks like you already enrolled, David. If you go to the last section of the module.
The very last section. Okay, I thought you said.
I think so. I mean, spatial dimension of the one before it. I'm sorry, yes, activity 2. I think 3 also does the same thing, but this one has, it talks about, right. Scroll down, I believe, I think, okay. Keep going, I think. They broke the learning activities into subsection, which is okay too. If you scroll down, I believe. Keep going, I guess. One more.
Matlab.
Yes, so it shows you here.
Okay,
right.
so here they're using a Hydroshare account, just as before.
Right, so this does it exactly like the way you said.
So it's exactly the same.
Right.
And if I go there and I open this with Matlab,
it should work. It should work.
In theory, it should,
yeah,
it should work.
Right.
So,
and the module actually has 2 sets of instructions. One on if you have Matlab installed on the computer, this is what you can do. If you don't, you can do it through through Quasi or Hydroshare, right?
All right. So
that might save you the time of figuring out how to guide the students on using that resource that David said.
So here you go. So there's a
I think it's new at .m. The code is there. I think that's the one. That.
And what I do, I guess I'm totally unfamiliar with Matlab. I don't.
Oh, okay, that's
None. What
yeah, I don't know if it will. I mean, but you can open it at least. The code will be there. I think. It's empty. So it's a new. Anyways, but the instructions are there. You can always read it and yeah.
Okay. So I believe.
So that's a nice resource if the students don't have a license of Matlab on their computer. I think the Quasi folks worked out this arrangement with Matlab, with MathWorks, I guess.
Okay, so now I've lost track of. I've got so many browsers open. There we go. So. So we worked with Collab through that module, and here are some examples. This one uses Hydroshare. This one uses Google Collab. We could also put the Matlab one here. Any questions on that before I move into the little bit I was going to say about intellectual property? There's a lot of computational capability. It takes a bit of time to digest, and I guess my suggestion would be I'd be happy to answer questions, but keep it simple for your students if you're gonna do it. It's you don't want to necessarily overwhelm with things that are too much. Belize might comment a little bit later on. She's joined us today and sort of taking over the role that Dan was doing. And she has developed her module quite extensively using Hydroshare. But the last little bit of the time that I have is to talk about intellectual property, so author credit licenses. So if somebody would like to use data in their module, but you're concerned that it's not your data set to share, you have to recognize that data is a form of intellectual property, and there's a tension between open data, credit, and intellectual property protection. So you can think of open data as paid for by the taxpayer, should be open to all. The reward is the satisfaction of feeling charitable and receiving gratitude. If you've done a lot of work on something, you want to get rewarded for it, recognizing that reputation is your reward if you're an academic often. So please cite me. And then if the ideas are yours to patent and profit from, it's the way the US capital economy works, and money is the reward. So sort of somehow we're kind of swirling around in this space with data and information on the internet. Here, I was just thinking, what's the way to think about how I approach these issues? And I thought of these as the principles for the way I like to think about things. Respect the intent of the person who posted the material. If it was put on the internet, there's an expectation that it will be used. Follow the law. Although it can be hard to determine what the restrictions may be, it's a best practice if you're publishing material to state the copyright to make it clear for others. But when you're trying to use material, it's sometimes hard, and often the default is that material on the internet is copyrighted. If you're in doubt, ask. So if you want to use some material that you found on the internet and it doesn't have a license that says that you can clearly use it, consider approaching the person or organization if you can and this might actually lead to a useful conversation that they give you updated information about better material. So you might build a network. And then acknowledge, indicate the source of the material you did not develop in a practical way that does not imply endorsement. You have to be careful that you don't say, well, this is endorsed by somebody when they haven't even read your module, so can't endorse it, but you're just saying you got this particular source from them, hopefully respecting their intent in terms of posting it. So there has been a lot of thought put into how information should be shared on the internet, and one of the active organizations in that area is Creative Commons, and they've come up with a number of licenses that give a standard way to grant permission. So if you see information that's available with a Creative Commons license, then you know unambiguously how you can use it. So CC BY means you can reuse it and you can give credit. CC BY with the share alike means you can reuse it and give credit, and you should also share whatever you make with it in this under the same conditions. And then there's non-commercial or commercial or distribute with attribution, but you can't make derivatives, and a lot of variations that that you may choose, or you may just put it in the public domain, and then there's no restrictions on use. So I think HydroLearn defaults to the CC BY option, or perhaps it might default to the CC BY with non-commercial use, but you're able to change it to just CC BY. So in terms of picking and attaching a license, think about attribution being nice, but it can become unwieldy. In HydroLearn, set the license at the bottom of the schedule and details page in Studio. So you can say allow others to copy, but for non-commercial purposes only, or you can say no derivatives, or you can say share alike. And with education, I always uncheck that box because it's unclear to me whether a university that charges tuition, which sometimes may be high, is commercial or not. And if I'm going to let other universities that charge tuition use my material, to avoid that ambiguity, I uncheck that. So then this is just an example that I picked up, and Emma said, we're running over time. Can I speed up a little? I think I'm almost done, and probably it's too late to really speed up. This is an example of how sometimes the best intentioned data policies are really tricky to work with. So Meriflux has a website that says all data should be properly acknowledged and contributors should have the opportunity to make intellectual contributions to papers and have the opportunity to be a co-author. And you have to list each site using its Meriflux site ID, and inform all data providers when publications are about to be published. And it complies with various DOE policies, and sharing and preserving data are important, and to the greatest extent, to the fewest constraints possible. I guess what to do, only research reuse is addressed. So educational use was not thought of when they developed this. So it's a bit inconsistent and ambiguous between what's there and there. So you sort of end up doing your best to abide by this and maybe contacting them. And maybe my take home here is, at least in terms of using this, you just sort of have to do your best. But whenever you have an opportunity, encourage people to use standard things like Creative Commons rather than make up their own rules that are sometimes hard to follow. And that was it from me. Sorry for taking so much time, Emma. Questions? Okay, well, I'll be around if anybody has further questions later on. And I think Doug is up next.
Yep,
So
great. Thanks so much, Dave. That was great.
I will stop sharing so you can, if I can find the button.
All right, thank you so much. That was great. So as we've been going through the hackathon, we began by you identifying desired results. That's where you define your learning objectives. And then you decided what's the acceptable evidence to show that the student had met those learning objectives. And that's where you created authentic tasks to demonstrate that. And then in the past couple of days, you've been developing those learning experiences, which is really just designing the instructional content. So when we look back at the constructive alignment, we're always iterating through this. Are your learning objectives good? Do we need to add more, refine those? You determine the acceptable evidence, as shown as assessment here in this tripod. And then we're working through to actually developing the content, instructional content to help the students be ready to demonstrate that mastery. So now we're really looking more deeply today and tomorrow about that alignment between the learning activities and the instructional content. So I think Jenny or Emad are going to give an example. Do you want to share, or you want me just to keep sharing?
I'll let you keep sharing.
Okay.
I'm having some bad storms right now. So at this point, we have been introduced and we are very familiar with the trifecta that is constructive alignment. And so the obvious next step is to assess the alignment between the three main pillars. So this is an example from our Bobeson module. And here, this learning activity is designed to address the third learning objective. So the student will be able to develop design storm hydrograph using the alternating block method. So the instructional content has been written in such a way that it can get students to that assessment. So the tool that we are going to use to determine if they could develop a storm hydrograph using the alternating block method. And that's exactly what this activity does. For us, this is an assessment tool to see, are the students achieving that objective to the degree in which we want them to achieve it? I believe that's it from this slide here. And so here we go, back to our scavenger hunt. We're gonna make this a very good challenge for you. You've got 10 minutes. So go ahead and open. Doug, if you don't mind, could you drop the link in the chat? And we are going to ask you to revisit the module that you're already very familiar with at this point. And we're asking you to do 4 things. So the ultimate goal here is we want you to assess the alignment between the content, the activity, which is the assessment, and the learning objective. So to get there, the first thing you have to do is find a higher order learning objective, and the best place to search for that is in the summary unit. And then you're going to find the instructional content that is related to that learning objective. And then you're going to find where that objective shows up in a learning activity. So we're going to try and find those 3 pillars in the module of your choice. And then once you have those 3 things collected, you can assess the alignment between those 3 things. And of course, we would like you all to record it in the scavenger hunt Google Sheet, as you have been doing so very diligently. So before I send you to your breakout rooms, do you have any questions of us? Fantastic. I'm going ahead and send you off. If you do have any questions, you can remain behind. And you have 10 minutes. We'll call you back in, let's say at 11:40, everybody, or 40 past the hour, wherever you are. Here we go. All right, closing the rooms. I think we definitely left them wanting more this time. Oh boy. Guys, I'm not sure how much of a conversation we can have here. They needed more time.
It didn't look like they had enough time to actually get to the assess part.
Mm-mm. Hi, everyone. Welcome back. So we can definitely tell that we left you wanting a little bit more, which is good. This was a big task, and we realized that 10 minutes is not enough, but we're trying to be respectful of your time with us and not take too much away from your partner work time. As you continue for the rest of the day, you can continue working on this because